Hello, everyone. Welcome. Thank you for joining us today to ALX conference. Today, I will make a presentation about network optimization with ALX via database integration. Our main focus will be on the database integration part, but also I will shortly mention about the using ALX and creating scenarios, etc. Our client is Coca-Cola İçecek, and this project belongs, the results belongs to from both Phoenix and CCI team. So it is a joint contribution to the results. Today, first of all, I will make a brief introduction about the case in terms of the business side. And I will mention which type of scenarios we have created, what are our aims, what are the issues, and what are the results. And then I will make a short introduction and to give some details about the data integration. And at the end, I will mention about the benefits of the data integration. Our customer is CCI Coca-Cola İçecek, is a multinational company. In this slide, you can see a sample country, the Turkey, from one of the countries CCI has been operation. The main problem that we want to use ALX is there were increasing transportation costs. Turkey is a huge geography, and there are some issues with determining ideal source matrix. So which distributor should get product from which plant, and which product should be produced at what level, this kind of questions we have. So I want to mention a little bit about the supply chain network structure of the CCI, Turkey. As you can see on the left-hand side here, there are more than 10 plants with more than 250 SKUs, and there are more than 50 production lines. So also, there are some distribution centers in Turkey, and there are more than 200 distributors. Plants, I will also mention product flow shortly. Plants can send products to distribution centers, and distribution centers can distribute these products to direct customers, like markets. Plants can make shipments to key accounts, like you can think at big retail markets, like these of key accounts. And plant can send to products to distributors, and they will make deliveries to the distributors customers, such as the market segment. Also, due to all plants are not identical, some of them producing different, have different product portfolio. Some others are bigger, some of them are smaller. The capacity utilization are at different levels. So plant also can send products to each other. So it is on the map here, you can see that the red dots here are the distributors, and the blue dots here are the direct customers that CCI is making distributions directly. The distribution here is a full truckload, FTL. It is not a milk run, only full truckloads are made shipment. And our optimization contains the gray area in the chart here. So it includes plants, distribution between plants, plant to key accounts, plant to distributors, and plant to direct distribution centers. So I want to shortly mention the aim of the usage of ALX here. As I said, there were increasing transportation cost issue, and also it is very important to allocate capacity utilization between plants to reach transportation cost, to keep transportation cost level at minimum level, and also to allow to increase demand fulfillment as much as possible. Additionally, there is increasing demand in Turkey. It is a good thing, of course, for any business, but in terms of transportation and capacity usage, capacity assignment to the plants, it also needs to be handled. So our solution is basically creating a digital twin for the supply chain that represents all different parts of the supply chain, plants, distribution centers, distributors, customers, direct customers. And by using the data behind it, we want to reach data-driven insight. How we can make transportation cost lower if there is a different product flow than the existing one. Additionally, there is a growth. We can divide the growth into two scenario types. First, we are examining the next 5 years, and we are understanding in the digital twin that these products are not enough to fulfill all the demands in 2 years. So we need to invest in this product to produce this product. Secondly, there are also some alternatives in terms of to decrease transportation costs. For example, let's say you are not producing a product in the mid part of the Turkey, but if you produce that, if you put that product in the production lines, that may decrease your transportation costs. Is it reasonable or not? We want to understand this kind of scenarios. And the results are actually very satisfactory. There we found that there is a significant decrease in transportation cost. There is a potential for that. Also, we identified optimal locations for new DC alternatives and for the investment plans. It can be a new line investment or a plant investment or a new mold investment to an existing line. So this is our business problem, business issue, why we need a digital twin, why we use ALX, and we got the results. Actually, this is a slide from the last year presentation. If the attendees are curious about the details about the results of these scenarios, they can check the previous year's presentation on that link here. So what are the data? Which data we are using to maintain the digital twin of the supply chain network? On the left-hand side, there is a screenshot of the ALX, and you can see the table names here. There are custom constraints, customers, DCM factories, and you can see the row numbers here. For example, for the demand for this country, there are almost 70K demand rows. There are more close to 500 locations. And there are more than 2,500 different paths, existing paths. So there are defined more than 2,000 product flows. So it is a very complex model. Behind the digital twin, if you provide the details more, your result is getting better. So which data tables we have used for create a digital twin? The first one is the customers. We all need a customer name ID and its geocode, latitude and longitude, and its type for the CCI network. If it's a direct customer or if it's a distributor, because some rules may change based on the customer type. Secondly, the demand. We need the demand of each distributor or direct customer by product and by period. So we are making, for example, we made a yearly, for a year optimization, and we use quarter. So we need to get demand of the in quarter base. So we got sites. We need, again, like similar to the customers, we need the location of the sites and the type. These are DC or plant. We need products, the product name ID, the weight, volume, and the price. For the production part, we need to create the digital twin. We need how many lines in one site, which products are being produced, what are their capacity, how many products can that line produce in 1 minute, the production cost of producing that product, and the available time, how many hours, how many minutes does that line is available for production. So, and another data table is vehicle. We have different kind of vehicles can be used based on the country. There can be wagons, there can be different tracks for 20 ton or for 10 tons, and the rules for this kind of tracks can differ. And also we have storages table. We need to know the capacity limit of the plants in terms of storage limit and the DCs. And also if there are initial inventory or the end inventory requirements, we need to know that. And we another important data table is also product flow. In the product flow table, we need to route which plant is used to deliver products to which customer and which vehicle type is being used, and also the transportation cost of that route by vehicle and by the vehicle type. Additionally, we can enrich the digital twin with inventory cost and handling cost. Inventory cost is important because the product is seasonal. In summer, the demand increases, but in the winter, it is not that much. So producing in the low season, storing it, and distributing it in the high season is a good idea, but the inventory cost is higher, then it may not be a good idea. We need to also contain that in the digital twin. So there is also constraints that we have to represent, because each line can produce different products, but there is a capacity limit for that. So based on the products and the production information, we are creating constraints for each line. Again, there are storage constraints. This is in terms of the number of PhD can be stored, but also shelf life can be represented. If, for example, some products are 3 months shelf life, then you cannot put them in your inventory more than 3 months. So these are the main data tables. The important thing is these tables are these tables need to talk with each other. What I mean is, for example, if you give a name in the customer table and demand to represent that demand, it should be same. And if there is a product in the demand, it should be the same with the product table. This is, of course, a very basic thing, but while creating scenarios for a multinational company that uses different alphabets, and the data is if the data is coming from different resources, they may use different data sources. That can be create some issues actually. So in summary, we can say that to create a digital twin of a complex model, we need a very detailed data table, data source. So it's now since a lot of different data source is required, and as you can see on the right-hand side the map, TCI has operations in 12 countries, and they are happy with the ALX experiment results, ALX optimization, and they want to roll out the Turkey project to the other countries. They want to create similar scenarios. They want to make supply chain network optimization for all of the countries they have operations. So that raises two main issues actually. The first, data collection and ensuring data integrity takes considerable time, because there are a variety of different data requirements, and these data belong to different departments. For example, if you need inventory cost, you may need to reach the finance. But for the demand, you need to reach the sales team. Or for production capacity, you need to contact the production team. So there is a lot of different teams are involving to collect the data, and this takes time, considerable time. Secondly, we have started the ALX scenarios, ALX usage in Turkey and in some other countries, but not all of the countries that CCI has operations ALX, doesn't have ALX knowledge or expertise. So they want to do it, but in terms of people number that knows ALX, it is very limited. So it is also an issue. They need to learn which tables are required, how they connected. ALX has very user-friendly structure, but still people need to learn. So the solution is, okay, there are very different data requirements. We need that, okay. But all the data is available in GCP. It is not in a structured way that we can use in ALX, but we have a database and we can reach different data sets that we ask for from the different teams, but we can directly reach these from GCP. So the idea is very basic. Let's collect all these data sets for each country from GCP, and then let's create a SQL server, because ALX can read data from SQL servers, and let's automatically create scenarios for all countries, and people do not need to try to gather data and spend time on data collection and scenario creation. So we came up with that solution. And we applied it, of course, and the result is very nice. We automated scenario creation for all of the countries, and within 10 minutes, that involves ETL process and the scenario creation process. The scenarios are ready for all countries. And secondly, the CCI has multiple ALX licenses, and different people from different countries can start to run experiments with, let's say, not zero, of course, but with limited ALX knowledge. So that's also an enhancement. In here, I will shortly give brief information about the pipeline of the data integration structure. First, as I mentioned, the data is in the GCP, Google Cloud Platform, but there is raw data. And then we want to take this data to SQL servers. ALX can read from SQL servers, MySQL server, Postgres servers, and we prefer to Microsoft SQL server. And then we, after several steps, I will go into details. We converted these raw data to the table structure that ALX wants to read, so to the ALX format, let's say. And at final, it is possible to get the experiment results, optimization results, into different reporting tools. You can still use Excel, but if you want to integrate it with Power BI, it is very easy if you want to create some custom reports or etc. So in the first part, Google Cloud GCP part, data is extracted from GCP, and for each table, for product, for demand, for all the data tables I have mentioned, an API is created. The APIs are created by the Coca-Cola team, by the way. And then we fetch the data from Google Cloud, and then converted the data to SQL Server type. And there are several steps occur. The first, we validate the data compatibility, because we want, before going to the next step, we want to be sure that all the data within the different tables can talk to each other and it is compatible. And also in this, as a second step, we, based on the country's requirements, we created data, let's say, staging tables, and then at the final step, by using these staging tables, we loaded data into ALX tables, and then it's ready to be imported for the user. In the third step, anyLogistix usage, like creating a scenario from Excel, a user, it's very user-friendly, can select import scenario from database instead of Excel, and after entering the credentials, all potential scenarios are listed, and they can select the required scenario they want to run, and they can run the experiment easily. And afterwards, of course, after running the experiment, exporting is an option, or they can use ALX interface. But if they want to do custom analysis, they can use reporting tools like Power BI or Python, or any other tool, Click maybe. So what we did is ETL and the SQL Server processes run periodically here, daily in our case, and always the updated version kept on ALX tables. So ALX users doesn't, if there is an update in demand or in the customers, if for example, if a distributor is not within our network, so they don't need to make manual calculations. The updated version is in the GCP, because all the teams within CCI are connected to GCP. They are working the data with that. I want to give a little bit details and the platforms and the tools that we use for the data integration pipelines. The first step, GCP to SQL Server. At first, we delivered to the client the templates, the table, which data we need, and what should be the template. And then they created the APIs for each table. And by using these data, we fetch the data from GCP, and we check the API results. If there is a missing part, or if there is unnecessary columns or lack of information, we made checks, controls on the data, and then we return them, please correct this, or this is like, this is okay, this is as we wanted. And with a teamwork here, we were able to get the desired table structures. And then in our case, with using Cloud Run, the data, after validating it, of course, the data is transferred to SQL Server. At that, Cloud Run and Python used mainly. At the second step, okay, now we have raw data, but not to get errors before running the experiments on ALX, we performed data compatibility check again. What I mean is here, a little bit, okay, we have data structure as we wanted, as we desired, but there can be some missing information. For example, you may have a customer in demand, but it may not exist in the customer table. So that's the problem. Similarly, we need geocodes. ALX has map integration built-in map integration and to be able to correctly calculate the transportation cost, we need geocodes of each customer. So we check on SQL Server if each customer has their geocodes available. Similar to that, we have more than 20 controls here, and we keep a status table for each country. And if everything is okay, there is a binary column 1 and 0. If everything is okay, it is 1. If there are some missing parts, then it is 0. And what that means, we can work on the country with status 1, and some data requirement missing parts needs to be fulfilled for the status 0. So these things are reported to data analysts, and then they examine what is the missing part, and then on the GCP they fulfill the missing part, and for the next run, the next day, after they fulfilled, it's updated again. Now when we check the data compatibility again the next day, we don't see that missing parts here. So we are keeping data consistency for each country. And secondly, due to the some countries have very big, and in terms of geography and product variety, number of sites, production lines, so it is hard to make optimization with loss of period. Sometimes to be able to get the results in a reasonable time, we create scenarios with quarterly period. For example, if Turkey, we did it quarterly. So while creating the raw ALX staging tables, all the data is created, aggregated to quarterly. So another thing is, as I mentioned in the data tables, we need custom constraints to be able to represent the capacities of each lines. So still, again, this part is also handled in the SQL Server, automatically created. And at the final step, we delete, because it runs daily, we delete the old scenario automatically from ALX tables and load the new scenario. And the next thing is ALX. As I mentioned, this is the easy part. User can just enter the credential and run the experiment. And after running the experiment, if desired, put it in a reporting tool, because ALX has very detailed and stable reporting structure. It is very easy to integrate to any reporting tool. So what are the benefits, main benefits here? I will shortly mention that. The first thing is the scenario creation time is drastically reduced from several days to the minute. And that makes ALX users to focus on analysis and running different scenarios instead of data collection. Secondly, Excel dependency is being minimized, so there are not other versions or eliminating confusion caused by spreadsheet using. And also, due to its CCIS has operations in a huge geography, it's a standardized data format. Sometimes different alphabets, for example, a Kirill alphabet, you cannot, within the Excel, you cannot find what you look for. If you can search with a keyword, but you cannot find it due to the different alphabet. So this kind of issues are solved. Again, data accuracy is being improved, and human errors, if there is human, there are possible errors. So these are eliminated. So additionally, this is also an important benefit. Everything is up to date. Without any manual effort, everything is updated. And another benefit is onboarding new employees to CCI to use ALX, because scenarios are being ready and they can run and they can examine the results. They can spend more time on the results. One other benefit is to collecting all this data to create a digital twin that supports scalable and efficient supply chain optimization for all the projects. It may not just be anyLogistix. There can be other internal tools or other project holders that may want to benefit from this database. They can also use that. So actually, what anyLogistix built-in flexibility from database import enabled us seamlessly import data from SQL Server. So this is the one thing that made easier for us to use database. Thank you for all attending.